So today we're troubleshooting the digital measuring accuracy issue on the ExactaCut. One of the first checks that I do is to make sure that if this is a electrically driven, is that the brake is working correctly with the motor itself. So the motor itself down here actually uses the electronic brake to hold everything in place. If the system of chain sprockets underneath there, all the way down to chain and sprocket underneath right there that you can see, if those aren't all tight, then the brake isn't going to work properly. One easy way to check that is to go ahead and reset down here. Go ahead and reset to the negative 0.35 and simply push and pull, and you can see the change in the display. So the fact that it went from negative 0.35 to negative 0.28 shows that you're losing accuracy because of the brake. So the couple things in the brake to check, one are to make sure that the springs here are actually compressed. So you shouldn't be able to really twist those springs down here. You shouldn't be able to twist those. If not, we need to add some compression. But more likely it's going to be in the chain and or sprockets themselves. So if the sprocket is not all the way up into the gearbox down on the bottom, it also could be, in this case, if I squeeze this chain, and I'm not sure if you can see it, but that far chain was able to be squeezed. So that should be essentially a stiff rope. So what we need to do is actually change where these increased this bolt here in order to push this down, in order to lengthen where that is, and it's going to then tighten our chain. It should be like a stiff rope. It shouldn't be you still should be able to wiggle it but not compress it, showing that it then would tighten and eliminate the change as you push and pull. So what we're going to do is go ahead and take the cover off of here in order to show us where the adjustment bolts are on the jam nuts, and then we're going to recheck to make sure that it's stiff, and that's one of the checks. So update on the digital measuring with the brake issue. What we also found was that one of the set screws on the sprocket here had actually come loose, and it had slowly worked its way, the sprocket had slowly worked its way off of the axis, and after removing the cover, we went ahead and loosened the set screws, tapped it back into place, and made sure that everything was vertical and in alignment, and made sure that the chain down here was nicely in the middle of the gap in order for the chain to be perpendicular to the shaft itself. And so what we're going to now do is go ahead and tighten all the set screws, to the set screws on each sprocket, tighten everything up. Then we're going to adjust the set screws, or the adjustment bolts, in order to set the tension first, and then we'll go ahead and we loosen these guys. You can see that they're spinning. Then we'll compress these about a full turn in order to compress this down in order to provide tension in the whole assembly. So afterwards we'll make sure that, again, the chain is taut in order for you to just barely be able to squeeze it, not like a stiff rope, or about like a stiff rope, as well as all the set screws are taut, and then we'll go ahead and make sure that the brake is working functionally. I want to point out that during this we did e-stop it and lock out, tag out, because hitting the joystick would move this while we're touching it, so that is definitely a safety hazard. We did remove the front shield in order to help with access, which is just a simple set screw and slide off. So everything's working, and we should be buttoned up here shortly. We are continuing to rebuild or reset the brake on the electric drive of the ExactaCut. We got all of our sprockets dialed in, both for position and straightness, and we got all of our set screws retightened. Here is what I want to show you is with about 5 pounds of force, you can see I'm able to squeeze it, but one chain is not looser than the other. I'm able to squeeze it ever so slightly with probably about 5 pounds of force. That's not going to cause any, you don't want it so rigid where you can't squeeze it. That's going to put too much tension on all of the components. We were able to do that by using these screws in order to apply even tension on both sides so that it wasn't one way or the other. We confirmed that the axle underneath was still horizontal and not tipped to one way or the other. After we set the proper tension, we tightened the jam nuts underneath the set screws or the adjustment bolts, and then only after that did we go ahead and tighten down the lock nuts on top of the springs. The springs, adding compression to the springs is actually going to be what is pulling the drive sprocket up against the gear rack. It's what's going to pull the whole thing up. So that's what's going to put the tension up and into the gear rack so that you can maintain engagement of your spur gear to your gear rack. And that's the system. So it's going to drive the drive sprocket to the lower shaft underneath, and then the lower shaft is going to drive on the gear rack itself. So these guys set the tension in the chain, and these guys set the tension of the whole assembly up against and up and under the gear rack. And that's about it. So we're going to go ahead and replace the guard here, replace the guard here, fire it up, and we should be good to go.